morning, students. Now I'm going to take a new lesson, right? So see 10th lesson. Yes, that is unit 10, communication system, right? So this is that 10th lesson. Yes, shall we go to that? Yes, to the lesson. Okay. So before that, what is communication, right? What is communication? Yes, I'll give you a simple definition. Communication is the process of passing information and understanding from one person to another, right? So it is a process, or other words, it is the process of transmitting and sharing ideas, opinions, facts and values, etc., from one person to another or one organization to another. Okay, so this is the communication. So communication is a very essential tool nowadays. Okay, so basics of communication. So the communication contains 3 major thing. One is processing, and another one is sending, and another one is receiving. Yes, this is the very essential thing. Now information also very essential thing. So information contains that is intelligence, maybe signal or data or any measurable physical quantity, right? So this is what information side. Okay, now I'll give you a small explanation about basic communication system from one person to another, or one system to another system, or one organization to another organization, right? Okay, now source of information. So the source may be the sound or pictures or data. These are the sources, right? So these sources are transmitted to the transmitter. So transmitter, it is a device which contains some elements present inside the transmitter. So from the transmitter, transmit the signals to the receiver. The receiver receive the signals through this link. So link, maybe that wire. I'll tell you later what is the link. Okay, the receiver again sent to the destination. The destination may be a mobile or system, that is computer, whatever. Okay, so this is the basic communication system. That is, for example, pictures transmit to the transmitter, and this transmitter transmit to the receiver, and receiver receive the signal, and finally transmit to the destination. That is user, right? Okay, sources. Okay, what is the sources? The sources is nothing but maybe speech, pictures, words, codes, symbols, commands and data. So any one of this is the source. So any one of this transmitter to the transmitter, right? Okay, now come to the transmitter. So any one transmitter to the transmitter. Now what is transmitter? This transmitter contains 4 major parts. One is oscillator. So oscillator to produce high frequency signal, basically, right? And another one is amplifiers. This amplifiers amplify the signals. Either the signal is very weak, it is amplified by the amplifiers. And third one is filter. The filter filtered the transmitted signals, and finally fed into the antenna. The antenna transmit to the which one? Signals to the receiver through space. Okay, now come to the link. So the transmitter transmit to the signals to the receiver through link. The links are maybe wire link, that is landline communication. The next one is wireless mobile communications, internet communications, and optic fibers. So these are the links. So only 3 links, that is wire link, wireless optic fibers. All the CCTV cameras, data cables are made up of optical fiber cable. So optical fiber cable is called as OFC. We simply called as OFC. Okay. Now, so the signals are received by the receiver. Right. Now, so now the receiver is receive the signals and send to the what? User. So what is that user or maybe output? Radio or TV or computer or telephone, teleprinter, telegraph, fax, internet. So these are the output. These are the what? Output. So these are the basic communication things, right? Okay. Now, so forms of communication. So what are the forms, sir? There are many forms of communication is there. Yes, I'll give you. The first one is radio broadcast. That is radio stations. Nowadays, n number of radio stations will be there. Yes, we called as FMs. Okay, it starts from 88 megahertz to 108 megahertz. Yes, so radio broadcast. The second one is television broadcast, TV. Yes, even local channels also. Yes, the local channels operating range only few kilometers, but if you go to that Sun TV, Vijay TV, these are all satellite communication system, so it covers wide range. Okay, so next one is telephony, telegraphy, and radar. Yes, radio detection and ranging, radar, and sonar. Yes, to find out the depth of the sea. Yes, and fax, email. Yes, we know that email, teleprinting, telemetering, mobile phones, internet. So these are the forms of communication. Yes, this is the form of communication. So now, types of communication. Yes, what are the types of communication, sir? Yes, one is cable communication, through cables communicating, yes, from one person to another person, that is through landline connections, right? And the second one is ground wave communications. Example, tower to tower communication. Yes, that is local tower. And third one is skywave communication. And the fourth one is satellite communication. Which one? Satellite communication. So all the channels, yes, under this satellite communication system, right? Okay, and the last one is optic fiber communication system. So yes, data cables and network cables are made up of optical fiber. So through optical fiber communications takes place. That's why optic fiber communication, right? Okay, now so in communication the signals are very important thing. Yes, right? Because signal is a very important thing. So what are the signals are basically? Yes, there are two signals. One is analog signal and another one is digital signal, right? Analog signal. Yes, what is analog signal? So analog signal is nothing but a continuous signal value which at any instant lies within range of maximum and minimum value, right? Okay, and the next one is digital signal. Yes, nowadays we are all using digital signal. So what is digital signal? This continuous signal value which appears in steps in predetermined levels rather than having the continuous change. Yes, I'll give you in graphical representation of analog signal and digital signal, right? Yes, analog signal we simply called as the voltage varying with the time, that is analog signal. So now I'm x-axis. In x-axis, yes, this pi by 2 is nothing but 90, 180, 270, 360. These are all. Theta is equal to omega t, that is displacement, and this is the time. Yes, Now this is y-axis, E and I. That is two different waves I'm used here. See this. So this is that what amplitude. E naught is the amplitude of this wave. So this is the amplitude, the maximum displacement of the vibrating particle. So this is what amplitude. So it will be vary with the time. Yes, it will be vary with what time. Yes. Okay, next. So E is equal to E naught sine omega t. Actually, yes, which one? Sine theta. Instead of theta only omega t. E naught sine omega t. So E naught is the amplitude of the wave. Okay. So because the signal sine wave function, the signal represented by sine wave function, that's why I'm used here E is equal to E naught sine omega t. E is equal to E naught sine omega t, right? Okay, yes. Next, I'm used another so the green color, that is another wave. This is also varying with time. Yes, this is I naught. I naught represent what? So this is I naught. This is amplitude of that second wave, that is green color wave, right? Because of the carrier waves signal usually sine wave. Yes, that's why we used what? Sine wave. Yes, sine. Okay. And I is equal to I naught sine omega t. Next, shall we go to the digital signal? See, this is the digital signal. The values are, that is digital signals are binary in nature. So binary values are 0 and 1. So 1 is maximum and 0 is what? Minimum. So these are the analog signal and digital signal. Yes, because in communication signal is very important thing. That's why we used here analog signal and digital signal, right? Okay. Next, modulation. Yes, so modulation is the process. Okay, we can't a signal directly apply to the transmitter. With the help of some process only we can apply the signals to the transmitter. So that's why modulation. So modulation, it is the process. Okay, so see that definition. So modulation is the process of variation of some characteristics of high frequency wave. Yes, the high frequency wave is nothing but carrier wave in accordance with the instantaneous value of a modulating signal. That is why important, modulating signal. Yes, modulation is the process of variation of some characteristics of a high frequency wave in accordance with the instantaneous value of modulating signal. Yes, because I already said carrier wave. See, what is our carrier wave? It is any new wave? No. Yes, it's nothing but high frequency wave, that is called as carrier wave. Both are same. High frequency wave, carrier wave, both are same. Because the carrier wave signal usually sine wave, sine wave. Okay, the carrier wave does not have any information, right? So this is the important thing. Okay, now I'll explain that what is modulation with the help of modulator. Now see, this is AF signal. What is AF signal? So audio frequency signal, that is speech is converted into signal. So audio frequency signal. This signal is fed into the modulator. Yes, so inside the modulator, modulation process takes place, right? Okay, now the same time high frequency oscillator. So this oscillator, radio frequency oscillator, to produce the signal, that signal contains high frequency. That's why high frequency signal. This high frequency signal is fed into the modulator. So the both audio frequency signal, high frequency signals are combined. It goes to modulation process. So finally the modulator gives some output, that modulated signal. Which signal? Modulated signal, right? So high frequency signal and audio frequency signals are, yes, combined in modulation. Yes, so this modulation process takes place, so it will give modulated signal. Yes, so this is the output of the modulator. This is modulated signal, right? Okay, now shall we go to the types of modulation? Yes, the types of modulations are amplitude modulation, that is AM, we called AM, and frequency modulation. Which modulation? Frequency modulation, we called FM. Next, pulse modulation. Yes, pulse modulation. And the fourth one is phase modulation, that is PM. So these are the types of modulation, right? Now I'm going to give, yes, explanation for amplitude modulation, right? Okay, see this amplitude modulation. That is simple definition: the process in which the amplitude of the carrier wave varies linearly with the message signal. This is amplitude modulation. Okay, now, so this is that simple definition, yes, for amplitude modulation. Simple definition, yes, it is a constant definition. Okay, see that the amplitude of the carrier wave signal varies in accordance with the instantaneous amplitude of the modulating signal. So here the carrier wave, which contains high frequency wave, right? So the amplitude of the carrier wave signal varies in accordance with the instantaneous amplitude of the modulating signal. So this is the definition for amplitude modulation, right? Amplitude modulation. Okay, now, yes, there are modulators. So are classified into two types, that is AM modulators. One is low level modulator, another one is high level modulator. The low level modulator generate amplitude modulated signal with small, yes, range, that is small signals, and must be amplified before transmission, Okay, and the second one is high level modulators. It produce amplitude modulated at a high power, usually in the final, yes, amplifier stage of a transmitter. Okay, so this is that amplitude modulators. Okay, with the help of the modulators only we can yes, give the output. Okay, next, see this diagram. Yes, it is easy to understand what is amplitude modulation, right? See, the first one is what? Message signal. Yes, that is speech is converted into, yes, signal format. This is signal. Yes, so this is their amplitude. So message signal. At the same time, carrier wave. So carrier wave is nothing but high frequency. See this number of peaks, yes, very high. That's why the frequency of this carrier wave signal is very high. Okay, now, but the amplitude is very, yes, less. Okay, now see this last one. So message signal, amplitude of the message signal and amplitude of the, which one, carrier signals are both are combined. That is which signal? Amplitude modulated signal. Yes, so see this minimum amplitude and here maximum amplitude. Yes, so envelope of modulating signal. So both are combined. Yes, that is the principle is superposition principle. Yes, so both are combined. The output is amplitude modulated signal. Okay, this is amplitude modulation. right? Okay, now see this. The amplitude modulated signal is represented by some equations. This is nothing but what? What is that? Modulating signal. This one is modulating signal because the signal is which format? Sine format. Therefore, I am representing Em, which is equal to Em sine omega Emt. Modulating signal. That's why Em here. Em is what? Amplitude. Yes, amplitude of this wave. Okay. Next, this is carrier wave. This one is what? Carrier wave. The carrier wave represented by EC, which is equal to EC sine omega CT. C for carrier wave. So EC, capital EC, nothing but amplitude of carrier wave. Okay. Now, so this is amplitude modulated signal. This is what? Amplitude modulated signal. Okay. So in this amplitude modulation, their frequency and the phase remain changes. Okay. The frequency and the phase constant. Okay. And their amplitude only changes. Okay. So amplitude modulated signal represented by this equation E, which is equal to EC plus EM sine omega Mt into sine omega Ct. This is amplitude modulated signal wave representation, right? Okay, see there below that E, which is equal to EC sine omega t plus MA EC divided by 2 into cos omega c minus omega m into t. Yes, minus MA EC divided by 2 and cos omega c plus omega m into t. Actually, so this is that cos omega minus omega t is that minimum amplitude. So this side it will be represented. This side is that minus. The maximum amplitude represented by cos. The maximum represented by what? Cos. Okay, cos omega c plus omega m into t. Okay, this is that amplitude modulation is equation. Okay. Okay, modulation index. Modulation index. This is that extra thing. Yes, you need not worry about this modulation index, right? Okay. So modulation index, that is represented by MA, which is equal to Ka. K is a constant. Em, the ratio of amplitude of modulating signal and to the carrier wave amplitude. Guys, modulation index represented by MA. Yes, if it is Ka which is equal to 1, then MA which is equal to the constant value for 1. Okay, MA which is equal to the ratio of modulating signal and a carrier wave signal. See, this carrier wave signal is represented by which color? Green color, and the signal represented by brown color. Yes, the output, what is output like this? Okay, their amplitude will be changes. Inferences of amplitude modulated wave. See, the first one is the amplitude modulated wave is the summation of 3 sinusoidal waves with the frequencies, that is nu c. What is nu c? Frequency of the carrier wave. And the difference between the frequency of carrier wave and the modulating wave is nu c minus nu m, and this has minimum value and this is the maximum frequency. Minimum and maximum frequency, namely original frequency, lower side band frequency and upper side band frequency. See, the nu c is the original frequency. and this is the lower sideband frequency. Nu c minus nu m is the lower sideband frequency, and nu c plus nu m is the upper sideband frequency. Okay, so if you are consider one signal, yes, the center frequency is maximum, but both side it will present lower sideband frequency and upper sideband frequency. Next, it has bandwidth. So the bandwidth required for AM, yes, the bandwidth represented by BW, it is equal to twice of the yes frequency of modulating signal, twice of that yes frequency of modulating signal. To nu m is the modulating signal. And see the next one is the amplitude EC of unmodulated carrier wave is made proportional to the instantaneous voltage of modulating wave. Which wave? Modulating wave. See this, the EM is equal to EM sin omega. It is the equation for modulating wave, right? Okay, now this is a frequency, is amplitude. So x-axis frequency, y-axis amplitude. Now, so this is that original frequency. This is the frequency yes of the carrier wave, that is original frequency. And see this Vc minus Vm is that lower band frequency, and Vc plus Vm is the upper side band frequency. Okay, so in yes picture, so the peaks are yes represent, these peaks are upper band and these are all lower band, and this is the mid frequency. Okay, now next, significance of modulating index. Yes, these are the yes graphical representation of amplitude modulated waves. Okay, so E is the amplitude of the carrier wave, and yes, their factors, and maximum is amplitude, and E minimum amplitude. Yes, so maximum amplitude which is equal to EC plus MA, modulating is index MA into EC. Yes, this is maximum is amplitude of the AM waves, right? And this is that yes condition for E minimum, that is minimum is amplitude of the yes modulating signal, EM is equal to EC minus MA into EC, right? So on yes manipulating, we can get this is that value, the ratio between the yes maximum and a minimum, yes, that is modulating index. So MA is the modulation index. Okay, so it has E max minus E minimum divided by E max plus E minimum. So this is maximum and this side will be what? Minimum. The ratio between the is intensity of these two, that is modulation index. So this is audio frequency signal, and this is that yes which one? Carrier wave. So no between, so no modulation, and this is amplitude modulated yes wave. The modulation index is 0.5 yes or 50%. So the modulation index of the amplitude modulated wave, so mostly 50%. And now suppose if that modulation index is equal to 1, definitely that wave 100%, yes 100%, that is 100 perfectly amplitude modulated wave, that's why 100%. So maybe the modulation index is greater than 1, definitely it will be what? 100%, that means modulated wave, that signal is modulated wave. So if modulated is modulation index is less than 1, so there is no wave, there is no modulated wave, right? Next, demodulation of amplitude modulated signal. So in previous case we discussed the signals are transmitted to the transmitter, in that some modulation takes place. So in previously amplitude modulation. So here come to this one, modulated signal. The modulated signal is passed into the S1S device, that is demodulator or detector. This detector detects the modulated signal and gives the output. So that is demodulated signal. So this demodulated signal is nothing but real that is actual output. Okay, so demodulation. So during the transmission process, modulation takes place. Okay, during the receiving process, demodulation takes place. That's why here explain the modulated signal fit into the demodulator or detector, it gives the output, that is demodulated signal. So this section will be receiving section, right? See, AM modulation or demodulation. See the source. Already I said modulator to produce the modulated signal. Yes, and the demodulator again modulate the signal, it gives the original output. Okay, now see this is one. So baseband signal, that is modulating signal, that is EM, the represented by EM we discussed already, and that signal is fed into the modulator. The modulator modulate the signal with help of high frequency carrier wave and gives the modulated signal. This modulated signal fed into the demodulator, again the signals undergoes the modulation, it gives the output. It gives the what? Output. See, band pass signal with frequency, that is modulated signal. Okay, and this is the original signal frequency. This is FM. I'll see that FM is nothing but modulated modulating signal, and this is modulated. FC is nothing but modulated signal, and FM is that original modulated signal. Okay, now actually voice, we are all using now, sir, the voice converted to signal. The voice is around 300 to 3400 hertz. Okay, now and other GSM cell phones are using 900 to 1800 megahertz. Okay, so this is the process of modulation and demodulation in amplitude modulated signals. Now this is another example for understanding. Carrier wave generated at a transmitter. Okay, the carrier wave generated at a transmitter and fed into the amplitude modulator. Okay, the sounds converted into audio signal with help of microphones, and that electrical signals are fit into the amplitude modulator. So both are combined modulation process takes place. It will produce amplitude modulator carrier wave. So the result is amplitude modulated signal. Okay, this is for your understanding. Okay, now this is also understanding to amplitude modulated signal. Okay, so here see this radio frequency and audio frequency, that is audio converted into there is sound converted audio signals with the help of microphone. Both are fed in the amplitude modulator, so both are combined together, modulation process takes place, and finally amplitude modulated wave. So this amplitude modulated wave fed into the transmitter, and the transmitter is fit into the transmitter attached to the what? Antenna. So because the antenna consists of TR switch, that is transmitter receiving switch. So the amplitude modulated signals are fed to the transmitter. The transmitter transmit the signals to the space. Okay, the other side, other antenna receive the signals, and demodulation process takes place. Okay, and finally it gives the output. Okay, so this is that process of amplitude modulated signals. And I'll give you difference between the frequency modulation and amplitude modulation. Yes, FM and AM. See, this is frequency modulation. See, this is the frequency, number of peaks, frequency high, here frequency low, here frequency high. So this is a frequency modulation. So in frequency modulation, we can change only the frequency of the signal. Remaining their amplitude and the phase does not change. Now come to the amplitude modulation. The amplitude of the carrier wave only changes, their frequency and the phase does not changes. Okay, and this is for what? Their input. Okay, now power relation in amplitude wave. So if the modulated wave is applied to a resistor of resistance R, then the RMS value, what is RMS? Root means square. Power dissipated in the form of heat. Yes, this is mathematical representation for power generated by the amplitude modulated wave. Yes, and root means square value, PRMS, and PC is power dissipated by unmodulated carrier wave. And if it is equal to MA, again I am telling you the modulation index is equal to 1, the power RMS value will be maximum. Yes, the value is 3 times of unmodulated carrier wave, divided by 2. Similarly, the power carried by both sidebands, that is SB is nothing but sidebands, is equal to PRMS divided by 3, that is power is dissipated, that is root means square value. Now I'll give that advantages of AM. So AM is amplitude modulation. Okay, so the first one is amplitude modulation is an easier method of transmitting and receiving speech signals. This is only for what? Speech signals. It requires simple and inexpensive receivers. Simple receivers enough to receive the signals. Okay, next, it is a fairly efficient system of modulation. Okay, now drawbacks, that is disadvantages. Okay, AM modulation, that is amplitude modulation, is more likely to suffer from noise, that is environmental noise. Okay, now the second one is appreciable energy is contained by 3 components of AM wave, and the sufficient energy can be saved by surprising carrier wave and one of the sidebands. This process makes equipment complex. Okay, next, the cost of such transmitters and receivers becomes practically more. Cost of such transmitters, transmitter cost and receiver cost becomes practically more. That is expensive. Okay, now this is what amplitude modulation, and what is the process inside amplitude modulation, and there's graphical, that is mathematical representation, and advantages, and even what? Drawbacks. Okay, now I'm going to give that applications of what? Amplitude modulated waves. The amplitude modulation waves, it is used to carry message signals in early telephone lines, and it is used to transmit Morse code using radio and other communication systems. Okay, and this modulation used in navy and aviation for communication as AM signals can travel longer distances. This is the use of what? Amplitude modulation. Now, okay, yes, so today class is over. Today we discussed what is communication, what are the forms, types, what is modulation, what is amplitude modulation, and their drawbacks and their applications. Okay, students, shall we? Yes, meet in next class. Okay, thank you, students.